go ahead and open up the 14.1 worked out. That's going to be our starting point for today. Oh, I should be sharing. Share. All right. So this one, okay, so this is our scatter plot. Wow, I should have made that look a little better than I did. You've got your residuals. Oh, I didn't do a residual plot on there. I should have. All right, so today what we're going to do is I'm going to basically give you a couple new formulas here. If I can find them. And we're going to do confidence and prediction intervals. Confidence and prediction intervals. Okay, so just as a reminder, what we were looking at here on our original scatter plot, we were trying to determine if, oh, this looks terrible, if there was a linear relationship between cholesterol and age. I must have been in a hurry when I did this the last time. Age, cholesterol. Okay. And it looks like there probably is. All right. So now, remember, so we're looking at people, these are people that are 25 to 65 years old, okay? Now, the idea here is, well, you might want to figure out, well, you know, I'm 30 years old, or I'm 40 years old, or however old you want to be. So what if we wanted to find a confidence interval for a specific age? Okay, so you could do that. Okay, and we think that it looks like your cholesterol naturally goes up with age. You might want to know what would be the mean for somebody who's 42 years old or something. Okay, so what we're going to do is the formula we're going to give you is y hat plus or minus t sub alpha over 2 times s sub e times the square root of 1 over n plus x star, and x star is the specific age you're looking at, a 30-year-old, a 40-year-old, whatever, minus x bar squared divided by the sum of the xi minus the x bar squared, which we found previously in our last lecture. So that's why we're kind of continuing on with the same stuff, because I don't want to recalculate it again. Okay? So x star, just to remind everybody, is a specific given value. Okay? Now, so that's one formula. Maybe I should stop sharing for a minute so you can see those formulas really good. Okay, we also can find a prediction interval. Okay, now the prediction interval is pretty much the same thing. Now remember, you can think of this as what would be the mean cholesterol level of, say, a 35-year-old person. Okay, 35-year-old person, if I look at my graph, go back here, let me share my graph for just a second. I mean, I could look here, a 35-year-old person would be about 200. You'd predict them to have about 200. You can get a better value here for what it would be. Now, but we know that so a prediction interval is similar to a confidence interval, except that remember that people are going to vary a whole lot more than an individual. Okay? So this time we're going to say, well, what would be a 95% prediction interval for somebody who's, say, 35 years old? This is going to be wider because it's tougher to guess. Okay, so the formula is basically the same, y hat plus or minus t sub alpha over 2 times S of E times the square root, and then everything's the same in here except for I'm going to add the number 1. Okay, 1 plus 1 over n plus x star minus x bar squared over the sum of xi minus x bar squared. Okay, so remember we've already found that from last time. We've already found that from last time, from our last lecture. Okay, so we're just going to reuse those numbers on this. Yes?
What does it say under fine prediction intervals?
Say it again.
What does it say underneath fine prediction intervals?
Fine prediction intervals, it's going to be wider because it's tougher to guess. Okay, there's going to be more variability among individuals than there is among the mean, essentially. Does that make sense? Okay, Sean?
So for the specific page one, couldn't you just put it into the equation we got?
We're going to put them both into the equation. Yeah. That's what we're going to do. Okay? So, let's say here, I'll make this a little bit bigger, but I want to find, so let's pick on somebody like Jonathan. Jonathan, can you tell us how old you are? Jonathan is 27 years old. Okay, would you like to know what your cholesterol should be according to here? Okay, so we're going to do a 95% confidence interval, and we're also going to do a 95% prediction interval. Okay, now having said that, let's look at my, oh, I'm not sharing. Okay, so we're going to find out what Jonathan's confidence interval and his prediction interval should be. Okay, so in order to do that, if you're just looking at the formula here, I'm going to need some sort of a y hat. Well, the y hat is going to be 27 because that's how old Jonathan is. We're finding his confidence interval. Okay, your t sub alpha over 2. Okay, how do I find that? Okay, we're using the computer equals t dot inverse two-tailed. How much do we want in the tails? 0.05. Well, 5% in the tails for 95%. Okay. Degrees of freedom. What's my degrees of freedom? It's going to be 12. It's n minus 2, right? So it's the same as what we taught last time. 12 degrees of freedom. Okay, so my t sub alpha over 2 is that. My s sub e, I think I figured that out on a different page. There it is. It's right there. Okay, so I'll just bring that over here. My s sub e equals, that's what this value here is, 19.48. My n is 14. My x star, oh, actually, I got this backwards. This is actually my x star. Now I need to figure out my y hat. Okay? Because we're doing this for, so this is Jonathan's age. Y hat is going to be what we would predict from our equation. So how would I find that? Plugging it into the equation. 1.3991 times 27-year-old Jonathan plus 151.35. Okay, so we would predict that a 27-year-old would have a cholesterol level of 189. Okay, so we're going to use that in there. Okay, so I've got to mix those two up. X bar was what? X bar, does anybody remember? We've already figured that out. It's the mean of this. We could figure it out again. It's the mean of all the ages. I think it was 42 as I remember. 42 years old, okay? And then the sum of xi minus x bar, I know we have that somewhere. The sum of the xi minus the x bar is right there. Oh, is there a square root in there? Let me make sure my formula, I wrote that down right. Yeah, I wrote it down right. Okay, so the sum of my xi minus my x bar, sum of xi minus x bar squared is this value right here. Okay? It's on the hypothesis test for slope. Okay, so that's a big number. Yep, that's correct. All right, so now I can start plugging everything in. I've got everything I need. So my y-hat's 189 minus my t sub alpha over 2 times my s sub e times the square root of x star, which is 27, minus x bar, quantity squared, divided by this number here. Oh, you know what? I forgot something. That's all right. Plus 1 divided by n. See, all those things should be highlighted by now. And now I may need to add another parenthesis. I think I do. Okay, now as you're doing this, of course, there's a real good chance you could make a mistake here. So as we look at this, what my question before I press enter is, does this number seem reasonable to you? Okay, so I press enter and I get 171. Does that seem reasonable? Yeah, because you know, we would have predicted 189, 171. That seems reasonable. Would 30 have seemed reasonable? Probably not. Okay, now I'm going to copy this. I'm going to paste it here. I'm going to change that minus to a plus. Okay, so we would, oh, actually, let me ask you guys a question. Tanner, give me a 95% confidence statement for this. You're confident? How confident?
We're 95%.
Confident that or here, we'll round it to 170 or 171.9. Well, we'll just round it to 180. 180.0, no, 171.0, 72.0, and 206.3. Okay. All right. Now, here's the deal. This is kind of cool because what I can do is I can copy this. And I can paste it here for my 95% prediction interval. And all I need to do is I need to add a 1 in here, plus 1. Okay, does that number seem reasonable? Yeah, okay. So now I'm going to copy and I'm going to paste that, change that minus to a plus. And Janessa, can you give me a prediction statement? We predict with confidence that a 27, in fact, maybe I probably should have been a little bit more specific on that. 27-year-old cholesterol is between whatever the numbers are, 143.3 and 234.9. Now, I actually made a mistake on the first confidence level. First confidence statement. What was the mistake? What was the mistake? I left out something that was very important. Very important word I missed. Because what's the difference between those two statements? Predict and confidence, which isn't much of a difference, right? but the mistake was that the mean, we're predicting the mean in this case, okay? That was the word that we left out. The mean cholesterol is between 172 and 206. But this is an individual, okay? Does it make sense what the difference is in those two statements now?
So what's the PI stand for again?
Prediction interval. Okay? So let's say, for example, Jonathan had a cholesterol level of 150. Okay? Would you say that that was outside the range of the confidence interval? Yes, that would be outside the range of the confidence interval because 150 isn't in that interval. Would that be surprising that Jonathan had 150? Wouldn't be surprising because that's within the prediction interval. So he's below the mean, he's significantly below the mean, but he's probably within normal limits on the low end of normal. Then we would say, well, good, you're not going to have a heart attack. Okay, Sean.
So comparing the lower and the upper to the y hat, make sure y hat's weak in those two numbers.
Well, that's not what I said. The y hat should be exactly between those two numbers. If the y hat is not in the middle of those two numbers, you made a mistake. So in our case, we were comparing we did a test on Jonathan. He was 150. We would say, good job, man, you're healthy, okay? So let me ask you this way, would 150 cholesterol be unusual for a person? 150 for a 27-year-old person. Would not be unusual. Would a mean of 150 be unusual? Yes, a mean of 150 would be unusual. Okay? More than one Jonathan. So if we found a bunch of Jonathans that are on the track team or something, we got a mean of 150, we'd say, wow, you guys have low cholesterol. That's awesome. Okay? If we found a mean of 220 among a bunch of NFL football players, let's say. Okay? Mean of 220, would that be unusual? Yes. Would a score of 220, would that be unusual for an NFL football player? No, because 220 is within my interval. Okay? An individual 220, it's on the high side of normal, but it would still be considered normal. Okay? If I took a bunch of NFL players, 50 NFL players, and I got a mean of 220, would that be unusual? Yes, that would be unusual. Okay? Does that make sense? So that all interpretation can be different. And of course, you could do this for any age. Okay? We're doing this for the age of 27. I think the book does it for the age of 42, so the numbers are different. But we could do it for any age, ideally between 25 and 65. I probably wouldn't want to go much outside that range. Especially given, oh, well, no, I guess that was the quiz. But yeah, we probably should check our residuals to make sure our residuals, in fact, let's do that really quick. Are our residuals okay? Well, that's labeled wrong, but anyway, that's what it is. Insert residual. Oh, no, I did something wrong. Oh, I did what, oh, Ethan's in my other class. Ethan likes to skip a step. Okay, let's do my residuals really quick. Okay, so if you got that as a residual plot, what would you say to yourself? I did something wrong. That looks like a straight line. Okay, you shouldn't get anything like that. The residual is going to be the observed minus the predicted. We're going to copy that down. Now we're going to do this versus this. Insert, scatter. Does that look okay to you? Is that a no plot? Probably, yeah. I'd probably say that's okay. Okay, so I can continue on with my analysis. Okay, does that make sense? I know that interpretation, that's the hardest part of statistics, is you can do the math, you plug it in, you get the right answer, now how do I interpret it? Okay? All right, so quiz tomorrow will be your last quiz on new material. And then it's the rest of the time is review. So see y'all tomorrow.